Welcome to Mathematics Made Easy with ADEX, where mathematical concepts will be explained in clear terms for easy understanding. You can also join us on all our social media handles for more information. Stay tuned as we play with numbers in today's class.
Good day, pals. Welcome to another edition of Mathematics Made Simple with ADEX. And for today, we are going to be taking solving and checking solution to equations. But before doing that, let me quickly do a form of recap just to go over what we've done before since when we started. We started then with the concept of direct numbers. Then after that, working directly into equations. For the equations, we started with the simple linear equations, and after the simple linear equations, then we considered equations with brackets. After equations with brackets, we consider equations with fractions. After the equation with fractions, last week we considered equations with binomial denominator, and as of last week, I made it clear there that there is no form of equation that you won't be able to solve precisely when it comes to simple linear equations. But for today, we are going to put everything we've done so far together, and after solving them one after the other, we are going to be checking our solution if it's actually right or wrong. Now, the reason why we need to do that is very simple. If you observe, there's one thing that is peculiar to mathematics textbook. When you check mathematics textbook, a good mathematics textbook must have answer at the back. That's to tell whoever is solving or the learner that, okay, when you finish solving, go and check if your answer is correct. But what if the question given does not have an answer available to that student? That means if the student is solving a question without using the textbook. Take for example, most of the time after the video, I always release questions. Now, after releasing the question, I'm very sure you don't have access to the answers. So if you don't have access to the answer, how then will you be so sure that what you've solved is correct even before sending it to my DM? Now, we are going to solve these questions on the board there. After solving the questions, then we are going to see how we can check. That's in case you're on your own and you come across any question, you should be able to check if your answer is right or wrong. So without much ado, let's take the examples here. So I'm going to be making use of my rough book here. So for the first question, we have 4x equals to 3x plus 5. And when we were solving the questions, then I remember I made it clear that all the algebra, you take it down to the left hand side. So the algebra here is 4x and 3x. So if this 3x crosses to the other side, it becomes minus. So that means here we'll be having 4x minus 3x, everything equals to 5. Now 4x minus 3x automatically gives us x. So when you have x equals to 5, now we've been able to solve this. Now after solving it, for us to now be sure if your answer is correct or wrong, that's the reason why we need to do it. We need to check. Now for you to check, write out the original question, and that's where I'm actually going for today. So this solution, that one is not my problem because I know you already know how to solve equations before. Now write out the original question you were given. The original question we were given here is 4x equals to 3x plus 5. Now for you to be sure of your answer, the final answer you got here, which is 5, start putting the 5 wherever you see x. Now in this place here, from your LHS, we have 4x. That means 4 into bracket 5 equals to 3 into bracket 5 plus 5. So that means what you have done there is this: 4x, which simply means 4 times x. That's the same thing we did here. 4 times 5 here gives us 20. Then equals to, here we have 3x, and our x from what we solved here, our x is 5. So that becomes 3 into brackets 5, which gives us 15 plus 5. So that means we have 20 equals to 20. So that means what we have there, the LHS is equals to the RHS. Now whenever you solve and your LHS is the same thing with the RHS, that means the solution you solved here is correct. But if after solving and you got your answer as x equals to 5, and when you are checking, the left hand side here gives you 20 and the right hand side is giving you any other number different from 20, then that means what you've solved is wrong. Now 20 and minus 20, they are not the same. Take for example, you solve and you have this one as 20 and this one is minus 20, then your mind is not telling you that, wow, 20 20, no, plus 20 is different from minus 20. So when you solve and you have 20 20 here, then perhaps you solved the correct thing. So let me transfer inside my notes. Solution. So for question 1, you have 4x equals to 3x plus 5. So we have 4x minus 3x equals to 5. That's when you collect your like terms. 4x minus 3x gives you x equals to 5. So let's check. Write out the original question, which is 4x equals to 3x plus 5. And here our x is 5. So when your x is 5, that becomes 4 into bracket 5 equals to 3 into bracket 5 plus 5. Then 4 times 5 gives us 20 equals to 3 times 5, 15 plus 5. So we have 20 equals to 20. So therefore LHS is equals to RHS. Hence our solution is correct. So since we've done that, we don't have any problem, so we can easily take the second question. And don't forget, when you are taking mathematics, always take it in a stepwise process. And just like the name of the program itself implies, mathematics makes simple. So when you are solving, look at the way I've arranged the questions here. I started with a very simple question. Don't jump into difficult question when you are starting the race. So the race to solve the question, even when you check some mathematics textbook, the way they will design the textbook, they will start with simple questions for you. That's to encourage you by the time you want to start solving. You don't start with difficult ones. Now, let's climb the ladder to the second one and see how we are going to solve it. So for the first one, we solved this. The second one now says 2x plus 19 minus 5x equals to x minus 5. These ones look a bit longer, but you don't need to bother yourself. Even though it's long, we are still going to follow the procedure step by step, and we are going to get the answer. Now, when you have 2x plus 19 minus 5x equals to x minus 5, what you just need to do is collect your like terms, put all the algebra on the left hand side, then the numbers, take them to the right hand side. So we have 2x. Now this minus 5x is still on the right hand side here. It's not crossing the equals to, so it remains minus 5x. Then the x we have here is having invisible plus, but when it crosses, it becomes minus x. Then everything equals to, from the right hand side, we already have minus 5 here. So the minus 5 stays because it's not crossing. We have minus 5. Then here we have plus 19. And when you have plus 19, the plus 19 is crossing the equals to the other side. They become minus 19. And when I was explaining this topic then, I explained that when you finish collecting your like terms, make sure you count the variables you have. 1, 2, 3, 4, 5. That means before collecting the like terms, the variable you have is 5. Now 1, 2, 3, 4, 5. After collecting the like term, the variable you still have is still 5. That's to ensure that you have not omitted any value while collecting the like terms. Now from the LHS, we have 2x minus 5x, which gives us minus 3x, minus 3x minus x, that gives us minus 4x. Minus 5 minus 19, that gives us minus 24. We've explained this. Precisely this was what we even started with, the concept of direct number, so I'm not going back to that. Now, when you have minus 4x equals to minus 24, what we just need to do here is just to divide both sides by minus 4, minus 4. This cancel this, then this is gone. We have our x equals to 6. So that means we've been able to solve the question correctly. But as usual, our target today is not for the solution, but for the checking. Now, to check if your answer is correct, rewrite the original question you were given, which is 2x plus 19 minus 5x, everything equals to x minus 5. And here we have x equals to 6. That means anywhere you see x here, you replace it by 6, which is the answer we got. That's 2 into bracket 6 plus 19 minus 5 into bracket 6. Everything equals to x, which is 6 minus 5. Then we start opening the brackets one after the other. 2 bracket 6 is the same as 2 times 6, which is 12. Then plus 19 minus 30 equals to 6. Okay, we can even evaluate that one at once. 6 minus 5 directly without wasting our time. So this one gives us 1. Now when you get to this stage here, you can easily look at the board and produce the answer. Now when you say you can look at the board and produce the answer, automatically when you add 12 and 19 together, that gives you 31. 31 minus 30 gives you 1. So we have 1 equals to 1. So that means our LHS is the same thing with RHS. Now just like the way we did the first one, when we solved the first one here, after checking, our left hand side here was 20, the right hand side was 20. Now coming to the second question here, our LHS here is 1 and the RHS is also 1. That means whenever you finish checking, your LHS and RHS must be the same. So let me write inside my notes and say how we attempt the third question. So we have 2x plus 19 minus 5x equals to x minus 5. When you collect your like terms, 2x minus 5x minus x equals to minus 5 minus 19. So this gives us minus 4x equals to minus 24. Dividing both sides by minus 4. So we have x equals to 6. So to check, we write the original question, which is 2x plus 19 minus 5x equals to x minus 5. So this is 2 into bracket 6 plus 19 minus 5 into bracket 6 equals to 6 minus 5. 12 plus 19 minus 30 equals to 1. 1 equals to 1. So for question 3, we have 3 into bracket 4c minus 7, then minus 4 into bracket 4c minus 1, everything equals to 0. So for this third question, what we just need to do is very simple. This is under equations with brackets, and we are solving equation with brackets. Use whatever variable is outside to multiply what is inside the bracket, and that's what we are going to be doing now. So doing that, we have 3 into brackets 4c, which gives us 12c minus 21. Then this one becomes minus 16c, minus times minus plus 4, everything equals to 0. So this one has now been reduced to a linear equation now. Now reducing it to a linear equation, we collect our like terms. Now when you are collecting the like terms, all the algebra left outside. So this is 12c minus 16c now equals to 0 minus 4 plus 21. So let's count. 1 2 3 4 5. 1 2 3 4 5. So that means we are not omitting anything. Now let's take the left hand side. Now from the left hand side, 12c minus 16c gives us minus 4c. Now let's now go to the right hand side. 0 minus 4 gives us minus 4. Now minus 4 plus 21. Now when you say minus 4 plus 21, we don't need to waste our time as usual. Now this one gives us 17. Now when you have 17, in this case here, what you just need to do is just for you to divide both sides by minus 4. When you divide both sides by minus 4, so this and this is gone. So we have c. How many 4 will you see in 17? Definitely it goes 4 times. So we have minus 4 whole number 1 all over 4. Now we have been able to do that. If you look at the final answer we got there, you can leave your answer here as minus 17 over 4. Or if you like, you can still leave it as minus 4 whole number 1 over 4. Now the reason I said that is this: when you have minus 4 whole number 1 over 4, if you are changing this one here back to improper fraction, just multiply this. Minus 4 times 4 gives you 16 plus 1, that's 17 all over 4, and you are still left with what? Minus. So in mathematics, precisely when you go to advanced classes, you don't really bother yourself with changing or converting it back to mixed fraction. If you are able to solve from this place down to this place, whoever is checking it knows that you know what you are doing. But if you can convert it to this last stage, it's advisable. You can convert it there, because you never can tell what the person is looking out for. That's the person that marks it. So let's now check if our answer is correct or not. Now for you to check if your answer is correct or wrong, I'm still going to make use of this place here. Let's say we have 3 into bracket 4c minus 7, then minus 4 into bracket 4c minus 1, everything equals to 0. Now The essence of this, like I said, is to do what? To check. Now, our final answer here is minus 4 number 1 over 4, which is the same thing as minus 17 over 4. That means anywhere we see C, we are going to be replacing it by minus 17 all over 4. That's we add here. So this now becomes 3 into brackets 4 into brackets minus 17 all over 4 minus 7. Let me change this bracket I'm using here. Let me use a curly brace. Then I close this, minus 4 into brackets 4 into brackets minus 17 all over 4 minus 1. Then I close this, everything equals to 0. This one looks a bit bigger, but irrespective of the size of what you are saying there, take it step by step. You are going to get your answer. And I say step by step, take the first one. The first one we have here is 3 into brackets 4C minus 7. So what I did here was I replaced this C by 17 minus 17 over 4. So that means wherever I see C here, that means 4 into brackets minus 17 over 4. This minus 7, this is it here. Then minus 4, this is minus 4. Then 4, this is my 4. C here is minus 17 over 4 that we got initially. Then minus 1, this is minus 1. Then I close the big bracket there. Everything equals to 0. Now, since you have been able to do that, let's now take the brackets one by one. The first bracket we have there is 3 into brackets 4, open a bracket, minus 17 all over 4. Then close this, minus 7. That's the big bracket. But if this is the big bracket, inside that big bracket you have a smaller bracket, and that was why I had to use the curly brace there to separate the two brackets that we're having, so that by the time you want to start solving, you start solving from the smaller brackets we have. The smaller bracket here says 4 into bracket minus 17 all over 4. So we solve this smaller bracket before bringing it to the bigger bracket. Then in this case here, when you have minus 17 times 4, now what we just need to do is just multiply your 17 by 4. 4 times 7 gives you 28. Carry your 2. 4 times 1, 4 plus 2, that's 6. So we have minus 68 all over 4. That's for only this 4 by 17 that we have here. And I say 4 by 17, that's 4 times 17, that gives you minus 68 over 4. I mean, where I'm having 4 into brackets minus 17 over 4 here, I will bring this value here. So that becomes 3, then my big bracket, which is minus 68 over 4 minus 7. Then I close this. But before closing it, this 7 is not just standing on its own. 7 is standing here as 7 all over 1. Let me take that part again, because this place here, if care is not taken, you might get missing on the road. Now, what I did here was I wrote the 3 outside. Then the bigger bracket, I wrote it. Then inside the bigger bracket itself, we're having another small bracket, which is 4 into brackets minus 17 all over 4, then minus 7. I extracted the smaller bracket that I'm having there. When I extracted the smaller bracket, I have 4 into bracket minus 17 all over 4, and that's what I have here. So when you have 4 into brackets minus 17 all over 4, then 4 times 17, that means I'm multiplying the numerator, because here we have 4 all over 1. That is invisible. You don't need to write it there, but it's existing, it's there. Now, when you have 4 times minus 17, I multiplied it here. 4 times 17 gives us what? 68. But it's also having minus here. That was why I had to put the minus. 1 that is here, multiplied by 4 gives us 4. So that was how we got the minus 68 over 4. So here now, I replace it by what is inside this place. So that means 4 into bracket minus 17 over 4. We've gotten that as minus 68 over 4. So I wrote it here. Now, minus 7. I wrote it here. Now, minus 7 is not just standing alone, it's standing as minus 7 all over 1. Now, I've done that. But I am not still done with the brackets there. Inside the brackets, you see that there's no more small brackets now. We are left with bigger brackets. Inside the bigger brackets now, we have minus 68 all over 4 minus 7 all over 1. This one now is just normal fraction. And don't worry, we are going to do it together. Now, the LCM of this 4 and 1 is 4. When you bring out your LCM, this is 4. How many 4 will you see in 4? 1. Now, multiply the 1 by this. That gives you minus 68. Now, go to the other side. Here, you have a minus. Bring down the minus. 4 divided by 1. That means whatever the LCM is, use it to divide your denominator. The LCM here is 4. I divided it by 1. So 4 divided by 1 is 4. 4 times 7 gives us 28. Now, in this case here now, you're having minus 68 minus 28, taking us back to direct number. And that's very simple. Now, when you say taking us back to direct number, minus minus, abstractly you are owing the first person 68, then you are owing another person 28. So that means altogether you are owing minus 96, everything all over 4. So that means inside these brackets now, what you have inside this bracket is now minus 96 over 4. Now ask yourself, can I break it down? Now, how many 4 will I see in 9? You see 2, because it will remain just only 1. So we write it out. We have minus, write out your 2. Now, when you remove this particular 9 here, you are still left with 1. So put the 1 here. That means you're having 16. Now, how many 4 will you see in 16? It will go 4 times. Now, another thing you can do to help your ministry is this. When you get to this particular stage here, if you know how to use your calculator very well, from this stage here, in short, all this nonsense here, you can use your calculator. But I don't want to introduce that for now. Maybe as we proceed, you are still going to be using it. But as a good learner, or let me say as a good student, you should be able to strike a balance between the two when there's calculator and when there's no calculator. So that's why I have to go through this stress of explaining it step by step. So here we have minus 24. Now that means everything we have inside this place here now is minus 24. When you have minus 24, so we have 3 outside, which is 3 into bracket minus 24. Now when you multiply, because when you want to open the brackets, you multiply. That's 24 by 3. 3 times 4, 12. 3 times 2, 6, plus 1, 7. So that becomes minus 72. So that means everything inside this first place here is giving us minus 72. So here now, I just come here, I put minus 72. Then I rub up all the solution here. Then we take the second one here. Now for the second one, don't forget you have minus, so leave the minus there. So we have 4, then the bigger bracket, we have 4 into bracket minus 17 all over 4. Close this, minus 1, close the bigger bracket. Now in this case here now, I may not really waste my time too much. I can just cancel out what I'm having here. When I cancel it out, 4 cancelling the 4 here. If I should do it that way, 4 cancelling 4, I'm left with only 17 here. So we have 4 into bracket 17 minus 1. That's minus 17 minus 1. Now we have minus 17 minus 1. So this one gives us 4 into bracket minus 18. Now, if you don't want to do use the method I used initially, you have 4 into big bracket, 4 into bracket minus 17 all over 4. Then here minus 1. If you open the bracket, you can just say 4 into bracket 17 times 4. 17 times 4, 4 times 7, 28. So you have your 2, that's 68. So here we have minus 68 all over 4 minus 1. Close your big bracket. Now 4 here, how many 4 will you see in 6? That will go just 1 time. Then you are left with what's it called, 2. How many 4 will you see in 28? 7. So that's still taking you back to minus 17, which we have here initially. So you don't need to waste your time. That was why I had to use this method. But in case you want to use this particular one, you are free. So here you are left with minus 17 minus 1. So that gives you minus 18. So I can rub up this now. And when you have minus 18, let me rub up this as well. We have been able to evaluate this. So 4 into bracket minus 18. What we just need to do is just for us to multiply now. 18 by 4. 8 times 4 gives us 32. So write your 2, carry 3. 4 times 1, we have 4 plus 1, 7. So don't forget we still have minus here. So this gives us minus 72. Now I rub this off. Now in this case here, everything we solved here gives us minus 72. Now, if everything is giving you minus 72, bring it back here. We have minus 72. Then everything equals to 0. That's 0 that we have on the right hand side. Now, if you are opening the bracket, minus times minus here automatically gives you plus. So here we have minus 72 plus 72 equals to 0. Minus 72 plus 72 is 0 equals to 0. And that gives you the final answer you are looking for. That means your LHS is equals to the RHS. And for this particular one here, I will advise, when you are watching the video, if possible, you can pause at interval just for you to internalize it. Make sure you get the exact step, because most of the things I rubbed off here, that's where you have the major work. The major work in the sense that this one here, somebody looking at it just seeing the minus 72. If you see minus 72, you think the answer just disappeared. No, I've rubbed off the main thing that led to this minus 72. So when you are solving it, try as much as possible to take it back. If there's any need for you to pause, do that. Then after pausing, then you go to the next step, pause, watch, based on your pace. So that's another advantage of watching or learning on your own. You learn at your pace. Nobody is going to rush you. Anytime you get it, you proceed. I'm very sure you are going to get it very fast. So for the fourth question, this fourth question is on equations with fraction. And the way I've calibrated the question, the first one is just a linear equation, the second one linear equation, the third question is on equation with brackets, and the fourth one is on equations with fractions. Now let's see how we are going to solve the equation with fraction. But before we start the solution, if you look at this, this is an algebra, this is an algebra, this is a number here. The algebra has to come inside to the LHS while the number crosses to the right hand side. Now if you are doing that, that means you are going to have 3x all over 4. This one is minus 2x all over 3. Everything equals to this minus now crosses to become plus 1 over 2 all over 3. Now the mixed fraction we have here, we need to change the mixed fraction to improper fraction, and when you're doing that, 1 times 3 gives you 3 plus 2, that gives you 5. So this now becomes 5 all over 3. So this now becomes 3x all over 4 minus 2x all over 3. Everything equals to 5 all over 3. Now since you've done that, this LHS here, we can do two things for this. Is either you multiply everything through by the LCM, or you just find the LCM and you start using it like fraction form. But the easiest way for me here is just for me to get the LCM, and after getting the LCM, I multiply each value there by the LCM. Now for the LCM of this, now the LCM of this is 12. We've done that before, so I'm not going back to that. So I will multiply the values one by 12. So I have 12 into brackets 3x all over 4, then minus 12 into brackets 2x all over 3 equals to 12 into brackets 5 all over 3. Now I've used the 12 to multiply each value, 12 to multiply the first fraction, 12 to multiply the second fraction, 12 to multiply the third fraction. Now I want to eliminate the fraction that is there. Now how many 4 will I see in 12? It will go 3 times. So that means this cancel this, we are left with 3. So that's 3 into brackets 3x. Now 3 here 4 times, we have minus 4 into brackets 2x. Everything equals to 4 into brackets 5. So we have been able to clear the fractions there. After clearing the fraction, now we have 3 into bracket 3x, which gives us 9x. Then this one is minus 8x equals to 20. Oh, this one is even direct. 9x minus 8x, this is giving us x equals to 20. So that means we don't have much work to do for that one. The next thing we need to do now is just for us to start checking. Now to check, as usual, the same way we started, and that's one simple thing with maths. Maths is just like following a pattern. Once you've known the pattern, you don't need to bother yourself about the whole thing. Now the pattern is this: for you to check, write out the original question, replace the answer you got in the original question, and solve. That's all. So the original question here is, check the original question, 3x all over 4 minus 1 over 2 over 3 equals to 2x all over 3. And our x here is 20. That means Anywhere I see x here, I'll replace it by 20. So this now becomes 3 into bracket 20 everything all over 4 minus, I can change this one directly now instead of me wasting time. 1 times 3 is 3 plus 2, 5 all over 3 everything equals to 2 into bracket 20 all over 3. 3 bracket 20, that's 3 times 20, that gives us 60 divided by 4 minus 5 over 3 equals to 20 times 2, 40 all over 3. Here, I can do this one directly and I can still reduce the fraction. If I'm doing it directly, what I just need to do is just for me to find the LCM, which will give us 12. But if I'm going like that, all the values I'll be having will be big numbers. I can easily divide this. When you say 60 divided by 4, 60 divided by 4, this is 2, this is 30, 2 here 1, 2 here 15. So that means I'm having 15 all over 1, which is the same thing as 15. So I can reduce this and bring that here. This 15 all over 1 minus 5 all over 3 equals to 40 all over 3. Now, the LCM of 1 and 3 will give me 3. Bring that out. 3. 3 divided by 1, that's 3. So 3 times 15 will give you 45. You are done with that one. Minus 3 divided by 3, 1. Multiply by 5, that's 5. So that means everything equals to 40 all over 3. So 45 minus 5 will give us 40 over 3 equals to 40 over 3. So that means with this, our LHS is the same thing with RHS. So with that, we have come to the end of the question, and if you're able to follow this procedure, there's no equation that you won't be able to solve. And if you're able to know how to solve, how to check for your solutions, it's going to help you a lot, because even in the next class, by the time we start the intermediate class, because from the maiden edition I said after the first phase we are going to be introducing ourselves to the concept of simultaneous linear equation and quadratic equation. Those are the two topics I placed in the intermediate level. Now, by the time we get to simultaneous equation and even quadratic equation, we are still going to need the knowledge of checking your solution. And it's not a different thing. That means if you know how to check, whatever answer you have gotten, replace it in the original question you are given. If LHS is equal to RHS, good, you got your answer. So that means this topic here is not ending here now. We are still going to need it even in the intermediate class. So that means, God sparing our life, next week when we meet, we are going to be starting simultaneous linear equation, and I'm very sure by the time we start that, you are going to enjoy it as well. So see you next week. God bless you.